I'm Vivek Nityananda. I'm a senior lecturer at Newcastle University, and I research insect vision and cognition. I'm trying to see how different animals perform various tasks and how they compare across each other. So you might have very different animals like humans and insects, and they both have to solve some task, like decide which stimulus is worth paying attention to.
I'm Théo Robert. I'm a postdoc researcher at Newcastle University. I'm studying attention processes in insects. Attention is the cognitive process that allows an animal to filter the information that is important to process in the environment. So it would prioritize specific visual information and filter out all the rest.
We often think of insects as having stereotypical responses, a bit like mini robots, that if you show them one stimulus, they will always respond the same way. But that's definitely not true. It depends on the circumstances they're in. It depends on what their internal state is like. That can change their response even to the same stimulus based on where they're at. We focus on two insects in the lab, and those are praying mantises and bumblebees.
When you go to work with bees and you hear about how bees are amazing and they can do all this type of thing, sure, they can do something very well. There are also plenty of things they cannot do. And to be fair, it makes sense. Like, an animal doesn't always have to be good at everything. They have to be very good at what allows them to survive and thrive.
With the mantises, another aspect that we're looking at is once the mantis has seen a target, whether it actually can stay focused enough to keep looking at that target and wait for prey to move before capturing it. So kind of how long can it hold its attention for?
There is generally two types of attention. There is one that is involuntary.
It's when something sudden or bright captures your attention almost unintentionally.
But there is one that you tune yourself. So if someone tells you have to look for something yellow, then you would actually tune your sensory system to detect yellow better.
A lot of what we do are inspired by human psychology studies of attention. And so we have tried to recreate those studies using computer monitors. So we use a kind of a cue that flashes on and off and see whether that biases which of two targets you might choose.
We tried one type of flash and it didn't work. So maybe bumblebees don't have this involuntary attention, but maybe it's just our flash wasn't the right one and probably we should keep looking. It's a clue in the right direction. It's just the beginning, one piece of the puzzle, but at least there is something there.
What we did find with the bees is that the level of reward that a bee might encounter in a flower changes their searching behavior. So if you have a high reward, they get much more focused on those flowers. But if you have a lower reward, they do choose those flowers, but then they have a more meandering path, which could indicate they're still searching for something better, if you like. We found the possibility that mantises can really hold their attention for a relatively long period of time, about a minute or so. There's this kind of state that's maintained by the mantis, waiting for a small movement, and then they will try to capture that prey. Another strand of work is related to the idea that an internal state can influence visual decisions that an insect makes, looking at how stressed states can influence whether they make more pessimistic or optimistic choices. We have seen that bees do make pessimistic choices after they've been physically stressed. So if they learn that one side has a high reward and another side has a low reward, after being stressed, they are more likely to approach the low reward. The fact that their visual sensitivity can be influenced both by reward and by stress, I think that's really surprising and kind of exciting. Those results are promising, and I like the fact that that might be something worth exploring. Insects have some kind of cognitive capacity. They're managing to make their way in the world, whether it's making comparisons, memory, choosing between objects. They seem to be able to do these things. And that was quite fascinating to think of, I guess, another kind of mind and what that mind might be like. And for me, that is the more fascinating story, that they could actually have solutions that we haven't thought about.
When I was kid, I wanted to study really big animals. I wanted to work on whales. That was what fascinated me. I studied biology with every option of animal behavior I could take. And turned out the professor we had teaching animal behavior were working on insects. I started to realize that insects have very interesting behaviors. They have very small brains, and despite this, they can do crazy things. If you start paying attention to insects, they are all around us all the time.